Good morning. And hi. It's I'd say welcome, but it's obviously most of you are from here. It's my first time visiting here in Estonia and Tartu, and you've all made me feel very welcome indeed. It's fantastic to be here. We're going to have an amazing day, and I'm going to kick things off today with a question. Now, I know normally the questions are at the end, and it's you ask the questions. We're going to turn it around. I'm going to do the question at the beginning, and it's a question for all of you. Do you think internet access is a fundamental human right? Now, this is one of those questions that, lawyers like to talk about late at night in hotel bars and things. But recently, it actually became a very immediate and real question. In February this year, February 28th, Mikhailo Fedorov, who is the Deputy Prime Minister of Ukraine and the Ukrainian Minister for Digital Transformation, he sent a letter to a guy called Horan Marby, who is the CEO of ICANN, the Internet Consortium for Assigned Names and Numbers. ICANN is it's the closest thing that the internet has to a government. And in this letter, Mr. Fedorov asked ICANN to do three things. He said, I would like your corporation to revoke permanently the domains RU, FER, and SU, which is the Soviet Union domain name. That's old, but it's still around. To contribute to revoking SSL certificates for all of the above-mentioned domains, and to shut down the two DNS root servers that are situated in the Russian Federation. Now, I have been to Ukraine many times, and it's a country that I love visiting very much. I have been there to speak at conferences. I've been to tech hubs. I've met people there who are running startups and software companies, all kinds of things. Digital transformation there is a pretty big deal, and I think that the Ukrainian Minister for Digital Transformation is probably very good at his job and knows what he's doing. And so I don't think he was surprised. I don't think he expected that the answers to these questions would be yes. But ICANN wrote back very quickly, and they effectively said, we understand and we sympathize, but we can't do that. And even if we could do that, we would not do that. ICANN has been built to ensure that the internet works, not for its coordination role to be used to stop it from working. Now, Mr. Fedorov sent another letter that same day to an organization called RIPE NCC. Now, some of you might have heard of RIPE. RIPE is a big deal, but RIPE is a little unusual. RIPE is not an internet provider. RIPE does not own any cables, any infrastructure, any data centers. But if RIPE disappeared, the internet would stop working. Not straight away. Tomorrow it would be okay. Next week it would probably be all right. But after a couple of months, you might notice there's some websites I can't seem to get to anymore. And email that you sent to certain domains, it would start to bounce. And eventually, the internet, as we know it, would cease to exist. And to understand why that would happen, we got to understand, what is the internet? What are we really talking about here? Because you've all seen these kind of diagrams, right? Where you connect to the internet and you've got your device and you connect to the internet, which is this cloud in the sky, like some massive internet, electric, digital brain database with all the web stuff in it. And, you can connect your device to the internet. And for most of us, this is how it works. We have a device. We pay a little bit of money to connect to the internet. I think between my mobile phone and my broadband at home, I pay about 60, 70 euros a month for internet. If you've got like a hotel with a couple of hundred guests, then maybe you pay a couple of €100. If you're a company that runs a lot of online services, your internet bill is probably a few €1,000 a month to get that bandwidth. But then you get to a point where some companies are so big that it doesn't make sense to talk about them connecting to the internet, because they kind of are the internet, because they own the cable and they own the mobile phone, the cell phone towers, they own the network. And so the way that these companies and these organizations connect is there is a network of things called Internet Exchange Points, IXPs. And if you're a big company and you want to, connect to the internet, you run one of your cables into an IXP, and then you go to all the other companies who also have cable in that IXP, and you say, hey, can we make a deal? Like, if you carry all of our traffic, we'll carry all of your traffic. Is that cool? And most of the time, they say, yeah, all right. that makes sense. The internet probably works better if we all agree to carry each other's traffic. So when I send you an email, it's going from my internet provider through maybe a dozen different networks, and I'm not paying any of those people, and they're not paying each other. They are peering agreements. These companies have just agreed that the internet is going to work better if they all carry each other's traffic. And RIPE NCC is the organization in Europe which exists to facilitate those agreements. They get about, so in Europe, RIPE NCC covers the European, some parts of Asia and the Middle East. They have about 20,000 members, universities, telecoms providers, big tech companies, and they coordinate agreements between all those members. There's another one, ARIN, covers North America. There's LACNIC, which is Latin America and Caribbean and South America. There's AFRINIC, which covers Africa. And there is APNIC, covers the Asia-Pacific region. And between them, these 5 organizations represent just about everybody on planet Earth who owns any cable. And the internet is the thing we get when all of those organizations agree to get together and carry each other's traffic. And so when Mikhail Fedorov wrote to RIPE and said, please could you disconnect Russia from the internet, RIPE went back and said, well, what you're asking us to do is to go to 20,000 different organizations and say to each of them, please look at all of your different agreements in all of your exchange points and all your data centers, and look at everyone you might be sending traffic to. And if you think some of that traffic might be going to or from Russia, you need to stop that agreement. But by the way, you can't shut off any other countries. You can't shut off Ukraine, because that's important. You can't shut off any of the Baltic states. And, RIPE came back and said, again, we can't do that, and even if we could do that, we probably wouldn't. We believe internet number resource registrations should not be used as a means to enforce political outcomes, and that doing so would have serious implications for the internet, not just in the Russian Federation, but in the rest of the world. Now, in 2021, October last year, Tim Berners-Lee, the creator of the World Wide Web, he spoke at the European Parliament at an event called Ideas for a New World. And, Tim has created the web, and which I think is pretty successful, He's a, really important pioneering figure, and his thing that he's working on right now is that right to internet access. He said in that address, we need governments, companies, civil society, and citizens to work together now to create a digital future where internet access is understood and realized as a basic human right. And if you want to go back a little bit further, in 1948, the United Nations adopted a document called the Universal Declaration of Human Rights, which doesn't talk about the internet because they didn't have the internet in 1948. But it does say, this is Article 19, everyone has the right to freedom of opinion and expression. This right includes freedom to hold opinions without interference, and to seek, receive, and impart information and ideas through any media and regardless of frontiers. And there is another article there that I think is relevant. Article 27.1, everyone has the right freely to participate in the cultural life of the community, to enjoy the arts, and to share in scientific advancement and its benefits. So we've got ICANN, we've got RIPE saying we think internet access is too important to switch off, even in terrible situations like this one. We've got Tim Berners-Lee, we've got the Universal Declaration of Human Rights. I'm kind of going to put myself in that camp. I think internet access should be a universal human right. But, before anyone goes running back to your hotel and starts complaining that the crappy Wi-Fi there is violating your basic human rights, we should probably figure out, what do we mean? What is internet access? Now, how about let's work with this as a starting definition. First of all, we'll say you have the right to connect to the internet, to the network, and be assigned an IP address for as long as you need it. If you transmit a properly formed, correctly addressed packet across that network, the internet will do its best endeavors to ensure the packet reaches its destination. And if anyone else, anywhere on the internet, they send a correctly formed packet to you, the internet will do its best to deliver that packet to you. Now, this doesn't say anything about what happens to the packets when they get there. This is not about, freedom of speech and the right to put your content on other people's platform. This is about ensuring delivery. This is the fundamental infrastructure of the internet. But implicit in this right to internet access is that nobody should be allowed to get in and mess around and interfere with your traffic, right? Now, this is a principle called network neutrality, and it is actually a really big deal. I want you to imagine for a second that the people who manage the highways agency, the people who run the roads, they decide they don't have enough money. They want to go and buy big TVs and, those Apple earbuds and yachts and all this kind of stuff. And they're like, how can we make more money? And the government isn't going to give them more money because the government's like, no, we pay you to run the roads. So they're like, all right, we control the roads, let's make some deals. So the first thing they do is they say, right, we control speed limits now. And they go to BMW, and they say, hey, we'll do a deal. If you give us €1 billion, we'll make a special rule that anyone in a BMW can go 170 kilometers an hour on the freeway. And BMW is like, oh, yeah, we'll jump on that, because imagine the advertising. BMW, the car without limits. And then Audi come along, and they're like, well, hang on. If BMW, we got €1 billion as well. Here, you can have €1 billion from us, 170. They go to Ford, and Ford are like, actually, our cars don't go that fast. How much for 150? And then they go to Toyota, and Toyota are like, Toyota drivers don't like speeding. We'll do 90. And then they say, right, that's enough money. Everyone else, 50 kilometers. That's the limit for all the rest of you. And then the car companies turn around and go, actually, just one more detail. We really like the deals we have with the big petrol and oil and diesel companies, so could we have no more electric cars allowed on the roads? And they say, yeah, that's fine. So they're making loads of money. But at that point, the road is not a public utility anymore. It is a product that is for sale to the highest bidder. And there are companies all over the world who would love to do exactly this to the internet. In the United States, domestic broadband, like home broadband, is dominated by 4 companies: Comcast, AT&T, Verizon, and Charter Communications. And there's something like 80 million people in the US who can only get one broadband provider. Like, it's that or dial-up. That's all you can get. And so it's almost, in some areas, it's a de facto monopoly. And in 2007, a group of users who were Comcast customers, they noticed that they couldn't download certain kinds of files from a pirate website that some of you might know about. And they went to the Federal Communications Commission, which is the government body in the US that supervises telecoms and internet access. And they said, hey, we're paying for internet access, and they're throttling it. And the FCC said, what are they throttling? And they said, never mind that. We pay for bandwidth, and we're not getting bandwidth. And the Federal Communications Commission, they issued an order to Comcast, and they said, you are not allowed to throttle your customers' traffic. Even if it's peer-to-peer file sharing that you think might be illegal, it is not your position to throttle that. And so Comcast said, all right, and they took the filters off, and then they sued the FCC. Comcast versus the Federal Communications Commission was the first time the issue of network neutrality had ever come before the court. And what happened? The lawsuit took about 3 years. And in 2010, the DC District Court ruled, and this is interesting because this is one of those legal verdicts. They ruled nothing about network neutrality. What they ruled was that in this very specific situation, the FCC did not specifically have the specific authority to force Comcast to do that. And in law, that's like secret code. That's like them going, look, actually we're on your side here, but we got to give it to the other because they won this on a technicality. So, maybe try again next time and watch out for the details. And so in 2010, about 6 months after that verdict, the FCC published a thing called the Open Internet Order, which said, we are going to safeguard network neutrality in the United States. First of all, transparency. If you want to run an internet provider, you have to tell your customers exactly what you are doing to their traffic. Second, you are not allowed to block them. That is not your authority. And third, you are not allowed to discriminate. You are not allowed to make one internet provider's packets go faster because Netflix gave you a deal and Disney didn't, this kind of thing. And this, before it even went into effect, Verizon, one of the other big ISPs, they sued the FCC and said, we are suing you before you've even started because we don't want you to do that. And again, it took a couple of years. And the court eventually came out and they ruled that, yes, the FCC did not have the authority to enforce this. Now, this was a bad day for network neutrality. It's seen as the end of the legal right to transparent internet in the United States. But it was a wake-up call for the rest of the world who watched this thing happen, and they went, can they do that? Can they do that here? We should probably do something about this. And so the European Union, in 2015, they drafted and published a thing called the EU Open Internet Regulation, which might look familiar. It says you have the right to transparency. Every internet provider in Europe has to let all their customers know how are we going to manage and filter traffic. You are not allowed to block anyone, and you are not allowed to discriminate in favor of traffic from certain providers. And this became law. This became, it's an open internet regulation. Every internet provider in Europe, and yes, I know I live on Brexit Island, but I'm in Estonia right now, so that applies to me too, is bound by these regulations. Now, I think that is awesome, and I think that is really cool and really exciting, and it turns out that normal human beings, they don't get excited about network neutrality, because normal human beings, they get excited about music and photos and shopping and holidays and cat memes and all this kind of stuff. And, the revolution that has happened within my lifetime is that all of that stuff happens online now. And the innovation that caused that revolution wasn't the internet. The internet's been around since the 1960s. It was the World Wide Web. Now, I have been on the web a long time. This is the original logo of the World Wide Web from 1990, and I've been on the web almost since this logo was a thing. I wrote my first web page in 1992, and one of the things that I have always loved about creating and building web pages is that browsers are an incredibly tolerant, forgiving platform. Do any of you out there work in C or C++, Java, C#, any of those compiled, statically typed languages where you write a little hello world program and you're like, yeah, that looks pretty good, and then you say, okay, compile it, and the compiler goes, no, human, you are stupid. You have missed a semicolon. We will not even attempt to run your pitiful excuse for a program. And you're like, oh, what? Really? You couldn't have figured that out? But you take a web browser, and you're like, all right, let's write a web page. It's got a head. There we go. And it's got a head, so maybe it has a face. And you can put a face on your web page. And you can be like, all right, it's got to have a body. And there's a heading 1, welcome to my web page. And let's have a line break there. And then we got a font colored blue, because I like blue. It's a nice color. And then I got, here's a picture of my cat. Image, source equals cat. Because I don't know about file extensions, because I'm like 13. I've never done this before. And the cat's name is Mac, and Mac likes a snack, and I got to close the body, and then I've got, all right, well, if it's got a head and a body, it's probably got to have feet, so also my web page has got feet. And then I can close the HTLM, hypertext language markup. And if you feed this code to a web browser, you get a page. And this worked in 1992, and this still works today. I literally fed that markup into Chrome to get that screenshot. This works. And this is a wonderful example of a principle called Postel's Law, which I think was really important in the adoption of the internet and the World Wide Web. This is John Postel. He wrote the specification for TCP/IP way back in 1980. And in that spec, he included something that's now called Postel's Law. Be conservative in what you send, and be liberal in what you accept. Now, there's a wonderful example of this principle, which has nothing to do with software or the World Wide Web. And I wasn't sure whether to kind of keep this in, but the world is a little scary out there right now. But the world has been scary before, and this is a story that kind of gives me hope. In 1975, the height of the Cold War, there was a joint space mission between the United States and the Soviet Union, the Apollo-Soyuz mission. And they had an American Apollo spacecraft and a Soviet Soyuz capsule. They rendezvoused in orbit, and they docked, and they took this photograph. This is Tom Stafford from NASA and Alexei Leonov shaking hands through the airlocks. And they had to solve a bunch of technical problems with that mission, but they had a problem with the language barrier, because all of the astronauts spoke English. And all the cosmonauts spoke Russian. And so they needed to figure out how are they going to communicate on this mission. And the rule they came up with, they sent everyone for 3 months of intensive language training. And the rule on the mission is the Russians all had to speak English and the Americans all had to reply in Russian. They had to speak the language they just learned and listen to the language they grew up with. And this, was a wonderful example of Postel's law in action. You had to be conservative in what you send because you've only been learning the language 3 months. You don't know that many words. And the people speaking back to you, they're speaking a language you've spoken your entire life, so you can help them figure out what you think they mean. And that's kind of like me when I first started building web pages. I'm Tom Stafford over here with my 3 months of intensive Russian training, and the web browser is Alexei Leonov going, that's nonsense, but I think I know what you meant. Was it this? And kind of, helping me get that right. And, this principle, be liberal in what you accept, browsers have always been based around this principle. It's one of the reasons why I think the web is so accessible as a platform. And so for my whole career, I've tried to kind of keep the other side, like my side of that deal, and be conservative in what I send. Now, the web has always been full of weird hacks and proprietary extensions and workarounds and plugins and Java applets and Flash and Silverlight and all these kinds of things that look really exciting at the time. But fundamentally, we had a thing called the browser wars, where the two dominant browsers, Netscape and Internet Explorer, they weren't compatible. They had different programming models, so you had to write everything twice. But if you punch through all of those layers of plugins and abstractions and shiny stuff, what you found at the heart of it was a set of standards, HTML, HTTP, CSS, JavaScript. And it turns out that websites that embraced those standards instead of fighting them, they've stood the test of time way better than any of the plugins and extensions ever did. Indulge me, folks. There's a web address there. Get your phone out and just scan that QR code, open up that website. Now, this is a website that I wrote a little while ago because I was building 3D models of Star Wars spaceships for use with the persistence of vision ray tracer because I'm a huge nerd and there's no point denying it. And when you get that page up and it opens, it looks like that. Now, any of you remember Star Wars Episode 1, The Phantom Menace, the movie that introduced the world to Jar Jar Binks? Now, let me get a show of hands. Was anyone in this room born after that movie came out? Anyone here kind of born after 1999? It's all right, hands up. I mean, I wasn't. I can't pull that off anymore. This web page is older than you. And I don't mean it's been online since before you were born. I mean, I have not touched it. I have not edited the code for this page since about the end of 1998. And this is what markup looked like in the 1990s, and it still works. You can open this page right now on a mobile device that didn't even exist when I pushed save on this for the last time. And it works because it just uses HTML. It uses tags, it uses font tags, and browsers have maintained this, wonderful backward compatibility. And I loved that when I was building sites in the 90s. And building websites today is just amazing. We have got so much awesome stuff to play with. All of the online collaboration tools, like when you join a Zoom meeting now in your browser, you don't need to install a plugin because there are native APIs for doing video streaming and webcams and microphones and audio and real time. And, there's a sensor in your phone that detects gravity. And literally, you can throw your phone in the air and write a web page that will tell you how high you threw it. We can do all this using state-of-the-art browser APIs. Being a developer and being a creator in 2022, the web is fantastic. But as a consumer, as somebody who uses the web, it's kind of frustrating. There's a lot of things about trying to use the web today which I find quite difficult. And I think a lot of those boil down to two things that the creators of the web didn't really get right: identity and money. Now, it's not that they didn't think about it. If you look at the spec for HTTP, they've had username, password, security headers forever. And if you dig really deep, you'll see this thing: HTTP 402, response, payment required, reserved for future use. Well, they reserved it in 1999 and still kind of haven't really done anything much with it. Now, we have, I think, three models of commerce that work online. First of all, you go online, you put in your credit card, and the next day something arrives in a box. And you open it up, you're like, yay, I got new stuff. And we're cool with that, because everyone's used to the idea that you pay money, you get the package. And the second one is downloads. We pay the money, we get the download. And maybe it's not quite so kind of tangible, but we're like, I want that movie, here is some money, now I can watch that movie. The transaction kind of makes sense. But then there is news, there is content, there is the stuff where what you want to pay for is actually the page that you're looking at in your browser. And that's the one where I think we have messed things up. It used to be, if you wanted to print a newspaper, you'd hire a bunch of journalists, you'd give them money, they'd write you stories, you'd put the stories in the newspaper, and you'd sell it. And people would pay €1 or $1 or however much for a newspaper that they'd read, and then they'd throw it away. And you'd put in, maybe the football scores and the crossword puzzle and stuff. But this transaction model was understood, but it only really made sense because when you put all that content together, people are happy to pay $1 or €1 or £1 for it. And when the web first took off, a lot of folks in traditional media were very worried because they're like, well, how are we going to sell newspapers on the web? Who's going to pay €1 to read a web page? Because they're not going to read all the articles. And we ended up with a bunch of different commerce options, and really, most of them kind of suck. Actually, I say most of them. There is one model for doing online content which I think works really well in certain scenarios. Did anyone remember kind of December last year when we started seeing little yellow and green squares popping up all over everyone's social media feeds? And suddenly it looked like everyone in the world was posting their Wordle scores every single day. Now, Wordle is beautiful. Wordle was not created as a product. Wordle was not a startup. Wordle was a gift. A guy called Josh Wardle, who makes online games. Does any of you see the place thing on Reddit at the start of April? That was Josh Wardle. He created a thing called The Button a couple of years ago, which also kind of went viral. And he created Wordle just as a gift for his partner because they were in lockdown and they wanted to play some word games. And he put it online, and he told a couple of his friends. And in December last year, somebody in New Zealand posted this on Twitter. They had this idea about using emoji tiles. And Josh Wardle liked this so much that he put a one-click share button into his game. And by January this year, 2 million people are playing Wordle every day. What's the population of Estonia, whole country? 1.3. So 2 million, that's kind of a lot, right? I mean, yeah, 2 million is a lot of people. If 2 million people buy your record, you get 2 platinum discs. 2 million, that's 10 times as many people went to see the new Spider-Man movie in its opening weekend, which kind of, saved cinema revenues around the world after the pandemic. So let's figure out, how much do you think it costs for 2 million people to play Wordle? We're going to work it out. Wordle looks like this. This is the whole game. There is no database, there is no backend, no servers, no cookies, no nothing. Wordle is 4 files, it's less than 200 kilobytes, and it uses local browser storage for everything, which is another cool modern web API that we have now. So we got 200K, you download that once, and that gives you the whole game and about 7 years worth of words, because it's all in local storage. So how much does it cost to serve 200 kilobytes to 2 million people? Well, 2 million times 200K is about 400 gigs, and this is Amazon. We'll put the whole thing in an S3 bucket, make that public. We're going to pay 9 cents per gigabyte for our data transfer there. So let's figure it out here. So 9 cents a gig is that much, which is that much per kilobyte. 200 kilobytes means that much for each player, $0.00018 per player. 2 million players. We are going to have to come up with the staggering sum of $36 for 2 million people to play Wordle. Now, Josh Wardle is probably thinking, wow, $36, that's a lot of money. And then he's thinking, what if everyone on the planet wanted to play Wordle? What if 8 billion people all download it tomorrow? I'd have to pay like $100,000 in bandwidth. I'm not up for that kind of exposure. And so what he did is he sold Wordle to the New York Times for a low 7-figure sum, is what they say. So I'm guessing a couple of $1 million or something. But let's imagine he hadn't sold it to the New York Times. Let's imagine he took Wordle to us, and he said, I want you to run this now. And you're allowed to make money, but I don't want you to make a profit. I just want you to run Wordle to cover your costs. So we're going to put up Wordle in like the game store, and we're like, okay, first problem, has anyone ever worked with a payment system that'll let you charge 0.00018? Now, the lowest valued currency in the world, does anyone know what it is? The Iranian rial. is 42,380 reals to the dollar. So maybe we could charge people 1 Iranian real to play Wordle, but actually it turns out the lowest coin they have in Iran is a 250 real coin. So we're not going to do this. I'm afraid we are going to have to make a profit. So we are going to say, charge people $1 to play Wordle for a year. That looks pretty fair, right? And the credit card company are going to take about 30 cents, maybe 30%. So we got $1.3, $1.4 million a year left to play with. But we've got a headache now because we're going to need to keep a database somewhere of all the people who've paid, because otherwise, what's the point? We need to know who paid and who didn't. So you get your game and you get the paywall. And we're going to need to hire a database developer and a security expert because we got all these email addresses, and we need to set up a company and hire an accountant to handle the revenue, and everyone's going to want a confirmation email saying they paid, so we need to find a SMTP provider and a UX designer to build the emails. And I'm like, is $1.3 million going to be enough? Like, can we actually do this? And that is the tragedy of the web. If you are prepared to pay a little bit of money, you can give things to everybody for free. But after that, there is this massive dip where you are not making enough money to make it worth the cost of having to make the money. We've got this red area here. There might be 5,000 people out there who would love to pay 10 cents to read your latest blog post. And you would love to get 500 euros for writing a blog post, but it's not going to happen. And it's not that they don't want to pay 10 cents because it's not worth the money. They don't want to pay 10 cents because it's not worth the hassle. And so we've ended up with a couple of options if you want to try and make revenue off the stuff you put on the web. One of them, you put it in a closed ecosystem. If you develop an app for iOS devices, you can go and put that in the Apple App Store, and they will give you money. And they handle security, authentication, payment, all that kind of stuff. You just put your app up, and they give you revenue. They take 30%. Okay, fair enough. And they can take you off at any time for no reason, without an explanation. And that's it. You just accept that. If Apple decide to switch off your revenue, they can. But you can make a lot of money with iOS applications. It's actually a very successful model because it's convenient. I can pull my phone out, go, I want that, bang, fingerprint, done. That's it. I own it now. And, there are other sites. There's Medium, Bandcamp, Patreon, YouTube, all of which they have some kind of revenue model, whether that's advertising or premium subscriptions, and you get a little bit of that. And, I make a bit of money off videos I have on YouTube, and I know people who are making a couple of 100,000 euros a year off videos they have on YouTube. But trust me, they are not making as much money as YouTube is making off their videos. So really, the only viable option if you want to make money out of your content is advertising. Now, in the beginning, web advertising was easy. You put up a web page, and someone goes, hey, I'll give you $50 to put my banner on your web page. And you'd be like, all right. And you'd link it to their website, and every time someone clicked on it, they go over there. Then we invented click tracking. And they're like, why am I paying $50 for 8 clicks? I'll give you 8 cents for 8 clicks. And I'll pay you at the end of the year. Then we invented ad rotators. Then we invented the idea of a broker. So instead of you dealing with the people who advertise, you just say, hey, you can sell advertising here, and somebody else out there, they put adverts on your website, and you don't know what those adverts are. It's all done using script. Now, the point where internet advertising went really, really bad is when they came up with the idea of running real-time auctions. Now, when I open a web page on a lot of sites right now, what happens while the page is loading is that an engine somewhere goes, hey, roll up. We got a white guy, British, 43 years old, lives in London. He likes cats, he likes guitars, he likes Lego, he likes computers. Last week, he was looking up rock and roll bars in Tallinn and Tartu. Who wants to show him an advert? Going for 10 cents, 5 cents, 3 cents, 1 cent, half a cent, 200 millicents, 50 milli, and it just goes down, 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 down. And eventually, there's a bunch of advertisers on this platform who have put in rules that say, if anyone who likes guitars is on your website before Friday, we will pay up to half a cent to show them this advertisement once. Now, if you want to see how bad this is, go onto any news website. This is the Mail Online, which is a horrible tabloid newspaper from the United Kingdom, and go into their cookie settings. And so we got this story about something that happened at Notre Dame. We're going to go over here. Now, we got a couple of, are you okay with us storing data on your device? Let's have a look on vendors. Those are the 3,290 companies who I have to say, yeah, this company is allowed to know where I've been and track my data and put cookies on my machine. I don't know who they are. The Daily Mail doesn't know who they are. Nobody knows. These are just all the people who have registered to participate in that real-time auction. There are thousands of these. And you know how oh, by the way, I love when you say yes. It says, great, thanks for choosing the best browsing experience. And I'm like, you should see my cat website. That's the best browsing experience. Now, how does it know that, 43, come from London, I've been Googling this, and I like cats, and I like computers, and all this kind of stuff? Well, it knows because when we live and breathe and click things online, we are leaving a trail behind us. Anyone here use Google search? Yeah, come on, of course you do. Everybody. Who pays for Google search? Nobody, because you can't. Because Google search is not a product you can buy. You are the product. And every time you do a search, you are leaving this little trail of digital footprints, and Google harvests up all the footprints until they become something that it can sell. And they sell it, and they make money. And they hire developers, and they're like, let's build an email platform that's free to use, and we'll harvest all the clicks. Let's build a mapping platform. Let's build a smartphone operating system. Let's build all these things, and we'll sign people up for free, and we'll gather their data, and we'll end up with this massive digital profile of everyone that is really, really valuable, and then we'll sell it until we're worth $2 trillion. And, this is starting a trend that I'm finding a little bit worrying. The web and the internet, they are built on open protocols and cooperation. HTTP, SMTP, DNS, as long as you're using the right protocol, I can build my website in .NET Core, and you can browse it in Safari on an iPhone. That's fine. I can build my website in Java, and you can browse it with Microsoft Edge. I can build my website in Ruby on Rails, and you can browse it with a screen reader because they're built on open standards. And so the cooperation there, it actually works. But we're beginning to see a significant trend where large parts of the web and the internet, they are converging onto individual platforms. Gmail has nearly 2 billion active users. That's a quarter of the human beings who are alive on this planet have a Gmail account. In the United States, more than 50%, 53% of email users in the US get their email from Gmail. Now, what if Gmail turned around tomorrow and went, we're kind of done with we're not doing email for other domains anymore. No, you want to Gmail somebody, you can Gmail them. And those 2 billion people, they're like, well, we didn't notice a problem. We can still talk to each other. What are the rest of us going to do? Are we going to wait for all of them to quit and move all their Gmail, or are we just going to suck it up and all get Gmail accounts so we can go and participate in what's going on there? Now, that's an unlikely scenario. But let me tell you, something happened to me a couple of weeks ago. I sent someone an email with an attachment with some directions to a place where we were going. And they're like, did you send me the email? And I'm like, yeah, I sent you the email. And eventually they did some digging, and they're like, oh, look, lots of messages from dylanbeattie.net were identified as spam in the past. Now, that's my domain. I've owned it for 25 years. I've never used it for marketing. I've never had a mailing list. I've never used it for anything except sending people personal emails. And it used to be, if your email went into someone's junk mail folder, that was their problem. But if Gmail decides your domain is sending junk, that's kind of my problem, So I spent the last couple of weeks setting up all these complicated domains and DNS records and things to try and say, no, this is my domain. Just let me send my email and stuff. And email is not the only game in town anymore. Hands up, who uses Slack? What about Teams? Discord? Signal? Telegram? Anyone have all 5 of these open on their laptop most of every day? Because you have to, I have clients who are like, join our Slack. And I can't use Teams to join their Slack, or Slack to join their Teams, or Discord to join their Signal or anything. These are all closed platforms where the only way to talk to the other people is to install the client for that platform. Now, one of the things I found amazing about, the revolution in remote and distributed working happened over the last couple of years is how many tools there are out there. Has anyone ever had a Zoom meeting with someone from Amazon? No, you haven't. Because Amazon have to use Amazon Chime, because Amazon have their own video conferencing system, and Microsoft have Teams, and everyone has their own platform, and you have to install and use all of these different things to be able to participate with these companies in these kinds of markets. Now, you're maybe thinking, well, yeah, but video chat and that kind of stuff, that's specialist. What about just regular websites? Like Reddit, I like Reddit. It's a fun website to browse around. If you open Reddit in the browser on your phone, it goes, hey, see Reddit in the Reddit app, big blue open button, or little muted, do you want to stick with your browser, continue, like a loser? And you're like, yes, browser, please. And it says, hey, this page looks better in the app. And you're like, no, it doesn't. And then you get, hey, the app has unlimited cats. And you've got two options here. You've got use the app, or you've got I'm a dog person. And you're like, well, okay, I'm a dog person. Oh, no, the app has unlimited dogs. That's a bait and switch and a half. And then you're like, I want to look at this thing I found on Software Gore that apparently is a software system crashed so badly it's not safe for work. And you get, hey, you need to view this not safe for work content anonymously in the Reddit app. Now, why do you think Reddit want you to use their app? They're funded by advertising. Now, I don't know the intricacies of Reddit's internal business model, but I do know two things. One, if you're using the app, they get much richer metadata, who you are, where you came from, maybe even, other data that you have stored on your device. But also, you can't install an ad blocker on Reddit's app the way you can with a web browser. And so by using the app, you are a more valuable product, and they can sell you to other advertisers for more money. And, it's not just Reddit and things. There's another trend I've noticed. I was out in Tartu last night. I had some dinner, and then I was like, I want to go somewhere and have a drink. So I went on my phone, and I looked up, rock and roll bars, and I found Underground, Tartu Koige Rocky Masabari. And I thought, Rocky Masabari, that sounds like my kind of place. So I clicked on the link to their website, and it said, hey, Underground is on Facebook. They don't have a website. They've got a web address that goes to a Facebook page. Now, fortunately, I'm a Facebook expert, so I managed to figure it out and went down and had a beer and listened to some music. It's a cool place there. But all of these platforms, Facebook, WhatsApp, Instagram, they are pushing companies and saying, hey, don't bother with websites and email and stuff. Just, use our platform. In India, there's about 200 million people use WhatsApp, and you can use it to, order takeout. You can use it to book a hotel room. You can get Netflix recommendations on it. And this is great. And it works most of the time because it's convenient and it's easy and it's free, and it works most of the time. October last year, October 4th, 2021, somebody was doing routine maintenance in one of Facebook's data centers, and they accidentally deleted all the routes from the internet to all Facebook systems. Now, a couple of things happened. First, Facebook, Instagram, WhatsApp disappeared, and this is the bad part, people couldn't log into their Oculus Quest headsets. That was the impact. Then a couple of minutes later, there was a massive spike in DNS as a couple of 100 million browsers went, hey, Facebook disappeared. Let's go and do a DNS lookup, see if maybe it's moved somewhere. Then there was a massive spike on Twitter and LinkedIn of people going, Facebook fell over. It took them 7 hours to get Facebook back up. The reason was they couldn't talk to each other. WhatsApp was down, Messenger was down, Facebook couldn't talk to their own people. The FB.com emails were bouncing. The people who jumped in their cars, and they couldn't get remote access, they jumped in the car, they drove down to the data center, they couldn't get into the building because the locks on the doors federate all their authentication to Facebook's infrastructure. And so when they accidentally wiped themselves off the internet for 7 hours, a company that's made trillions of dollars building next-generation communication tools, the way they had to fix it was to use open standards. Email, text messages, telephone calls, believe it or not. Now, at the start of this talk, you remember I showed you this map of the internet. And some of you might notice that there is a little piece of this map which doesn't have any friendly color coding on it. Antarctica, the white continent. Now, Antarctica is home to in the summer, there's about 5,000 people live there. Scientists, researchers, support staff. In the winter, that number drops to about 1,000. And, like everyone else, those people, I believe, have the right to access the internet. But it turns out getting online from Antarctica is really complicated. There are no cables running to the entire continent of Antarctica, and they're way too far away from anywhere to use microwave or radio connections, so they have to do it using satellites. Now, satellite internet, that's a thing we have, right? But satellite internet is based on satellites in what's called a geostationary orbit. It's about 38,000 kilometers above the equator. You get your satellite dish, you lock it in position, because the satellite basically doesn't move, and you're done. Antarctica is so far south, you cannot see geostationary satellites. They are below the horizon. So to get online from somewhere like this, McMurdo Station, for about 10, 12 hours a day, you can pick up a signal from something called the Tracking Relay Data Satellite Network. Anyone got 3G, 4G, 5G on your phone? You have more bandwidth in your pocket than the whole continent of Antarctica. They get 25 megabits on a good day for about 10 hours. The rest of the time, they are reliant on something called the Iridium satellite network. Iridium runs about 66 satellites. They're in low Earth orbit, about 800 Ks up, and they will provide data and voice services to anyone, anywhere on the planet for a price. To send one plain text email on the Iridium satellite network costs about $3. And I found this out the same day that I found out Gmail was sending my mail to spam, and I thought, God, imagine if you spent $3 to send someone an email and it went into junk. And then I immediately thought, hang on, what if you could spend $3 on an email to guarantee that it wouldn't go into junk? Now, I know the idea, hey, what about network neutrality? You can't charge people for email. Well, no. We're not talking about interfering with the delivery. We're just talking about what happens when we get to the other end. And, I said earlier, I thought there were two things the web didn't get right, identity and payment. Maybe we missed an opportunity here. So we're going to go back in time a little bit, and we are going to reinvent email, circa 1990. Because in the 90s, when you got a mobile phone or anything, you paid. You paid for your text messages. You would get 50 free messages, and anyone after that, you'd have to pay for. So we are going to wire into this. We're going to build a system where sending email is going to cost money. You're going to pay 1 cent every time you send an email. How can we do this? Well, let's remind ourselves how email actually works. Someone wants to send an email, so the sender, they connect to DNS, and they say, hey, who handles email for Dylan at dylanbeattie.net? And the DNS infrastructure says, hey, it's this server here, mail.dylanbeattie.net. And then the sender connects to mail.dylanbeattie.net and says, hello, I've got an email here from /@gunsandroses.com. And for a long time, my server just went, oh yeah, okay, cool, / he's my friend. Why would anyone lie about that? And boom, go ahead, send your message. This is why spam became such a problem, is that most open SMTP relays would just be like, yeah, you can send an email you want. We don't care where it came from. Why would anyone lie about the email that they're sending? So let's mix it up a little bit. What if we said, I mentioned earlier, DNS records that we can use now to authenticate domains, SPF, domain key identity management, DKIM, and a thing called DMARC now. But those are all based on authenticating domains. What if we authenticated individual emails? What if the sender, they ping the DNS infrastructure, and they get my mail server address, and then they send a message to me saying, hey, I got a message here from /@gunsandroses, here is the message ID. And my mail server then says to DNS, hey, who's handling email for gunsandroses.com right now? And DNS says, Guns N' Roses mail server is over here. It's called Beatrice. For some reason we don't understand. So my mail server connects to Beatrice and says, hey, did you send this ID from / to Dylan? And it says, yes, we did. And I get an email, and I'm like, woohoo, awesome, I have email from Guns N' Roses. Or, far more likely, that server says, no, I did not send that, and that's it. End of, no spam, probably not really / from Guns N' Roses. Now, this solves the problem of spoofing. It doesn't solve the problem of somebody goes out and I'm just going to get a domain so I can send spam email. Now, SSL is the system that we use to authenticate domains. We have secure sockets, and we have certificates. And I could go online right now, and I could go and register digit-tattoo.com. And because I own the DNS, I could get a certificate for it. Because we care far more about encrypting traffic than we do about verifying somebody's identity in this day and age. But that's not a technical problem. That's a social problem. We could very easily use SSL to establish a web of trust that says, hey, this person's sending email. Who trusts them? And who trusts them? And who's checked whose paperwork? And all right, we have a shared authority when it comes to trust here. We can do that. We can use the SSL certificate infrastructure to validate that this mail is coming from where it came from. So the mail comes in, and my server says to them, hey, did you really mean to, pay for this email? And the server goes, yep, he did. We've got the records. Here it is. There is maybe some, cryptographic handshaking goes on just to sign those things on both sides. But we've done it. We've established an email network. It looks a lot like the one we've got, but there's a lot less spam, and there is email by email validation, and that's where it gets interesting. Because imagine I am sending some important paperwork to my lawyer, and I want to make absolutely certain that it does not disappear into anyone's junk mail folder. So I can go in and I can say I want to pay 50 cents to send this email. And their mail server receives this, connects to my mail server, and says, did Dylan really attach 50 cents to this email? It says, yes, he did. Here is the signature for it. They exchange those signatures. Their account balance goes up by, well, my ISP takes a cent. Their balance goes up by 49 cents. Mine goes down by 49 cents. And next time they sign into their email, they've got like the email equivalent of one of those shiny gold envelopes that you sometimes get in the mail. And we've just turned email into an identity that can actually spend money. You want to play Wordle? Yeah, no problem. Email play@wordle.com, attach 10 cents. You get an email straight back saying, hey, your Wordle's set up. Click here, go into play. Now on the other end of that, they might have a bit of a problem because play@wordle.com now has $187,000 in its email account. And you're thinking, well, how are we going to cash out with that? You know, how do you turn that back into something you can spend? Now, one approach is you do what the banking system does, is you keep a record of everyone who sent anyone else any money, and then overnight or at the end of the week, you're like, right, Gmail, US $15,000, Yahoo, $12,000, Outlook.com, $6,000. You're going to lose some of it in the wash. Some of this stuff, the domain will have disappeared, that kind of thing. But this is not that complicated compared to how banking actually works. But we've also turned email into a de facto currency. You put up a blog post. You're like, here it is, 500 people read it, they pay you 10 cents each. Suddenly, you have 50 euros in your email account, and you got that game on Steam that you're looking at and thinking, well, I could just email them the 50 euros, and I could buy that. And email has now become currency in its own right. You can actually spend it instead of having to turn it back into, you know, dollars or euros or whatever. Now, if you're thinking, would that ever actually work? Something almost exactly like this has worked already. When the first mobile phone networks were launched in Kenya, in Africa, around the year 2000, very few people in Kenya had bank accounts. Only about 20% of people there had a bank account. So all the mobile phones that they launched were prepaid. You had to pay as you go. You had to go into a store, buy a top-up card. And what they realized very early on is that people were phoning each other and reading out these numbers and using it as a way of transferring currency. Then they introduced a way of sending currency by sending text messages, and airtime became a way of paying for things. You didn't have to cash out. You could pay the doctor by sending them a text message. You could pay someone to fix your bike. You could buy a beer by sending a text message. In 2007, Vodafone partnered with Safaricom, and when we should probably turn this into something like a little bit more structured, and so they launched a service called M-Pesa, which was digital currency that does not use a bank account. It's completely independent of the banking system. And M-Pesa is still in use in Kenya today. It's in use in Tanzania. They tried launching it in a couple of other places around the world, but Kenya was just the right place at the right time with just the right infrastructure, and it solved a real problem. M-Pesa was a path out of poverty for something like 200,000 households because suddenly they had a way that they could save money and they could transfer money securely. It hasn't caught on so much around the rest of the world. Now, maybe there was a point in the 90s where if we'd got the marketing and the tech just right, we could have got email payments to catch on. I think we've probably missed that window, and the web is maybe a kind of less pleasant place for it. But while we're back in time fixing stuff that we got wrong, there's two more little things I want to solve. One of them, I like this pattern. There's a thing you can do with Slack now where instead of having to remember your password, you give it your email, and it's like, I'm going to email you a link, you click the link, and boom, you're signed in. I love this pattern. I want to turn this pattern into a protocol and build in support for it into clients. I want to be able to, you know, sometimes you go on a website and you're like, can you find the store here that's nearest my location? And your browser says, hey, this website wants to know where you are. Now, it does that because, one, that changes all the time because we're always moving around. And two, it kind of doesn't make any sense for anyone else to keep track of my data because that's really stalky, right? But what if we extended the same pattern to other kinds of authentication and personal data? What if I go onto Amazon, I got to sign in, and it sends a protocol message back to my client that says, hey, Amazon.com wants to sign in as Dylan, and it wants to know where you live right now. So they don't store that data. That's my data. I store it with my internet provider, somebody I trust to look after that. And then the message pops up going, oh yeah, and by the way, Amazon would like to pay $1 to access your browser history. Because that's my data, and it has value. Maybe if there's money to be made here, I'd like my cut of all that money. Now, we have all the protocols that we need to build this. We have HTTP, we have JSON, we have Speedy, we have WebSockets and OAuth 2 and OpenID Connect and token-based authentication. These kinds of systems, we could build them. And there are some ideas here that maybe will catch on easier than others. But I'm sure there's also a bunch of people out there thinking, hey, and we can do it all with blockchains, right? This is my collection of blockchains right here. Now, there is a lot of excitement going on at the moment about blockchain and cryptocurrency and NFTs and the decentralized autonomous organizations, DAOs or DAOs, however you pronounce that. And a lot of these people are talking about that. They're also talking about something that they call Web 3.0. And now there's a slight kind of problem that I have with the whole idea of NFTs. By the way, I stole this. I right-click Save As. And this is worth $20,000. But also I stole it in London, and now I'm here in Tartu, which makes me an international art thief, which I think is pretty cool, right? The problem with NFTs is when you say NFTs, half of your audience stops listening, and then you say are a really bad idea, and the other half of your audience stops listening. So it's difficult to have a kind of informed conversation about it. What I will say is last year, somebody paid nearly $3 million for an NFT of Jack Dorsey's first tweet. By the way, you know how you spend $3 million on a tweet? You find someone who goes, hey, you want to buy a tweet for $3 million? And you give them $3 million. And don't ask any difficult questions about what exactly you just bought. That's how it works. This guy put that tweet up for sale on CoinSea last week with a reserve price of $48 million, and it went for $280. So maybe he just picked the wrong week to try and sell, or maybe the whole kind of, NFT bubble thing is coming to an end. But when I look at all the discussion that's taken place around Web 3.0, I was around for Web 2.0. I was there when everyone was getting very excited about the second generation of the World Wide Web. And, with hindsight, everyone has kind of gone, oh yeah, Web 2.0 was social media. That's what we had. But at the time, people were talking about all kinds of things. Web 2.0 was about microformats, so we could build better search. No, Web 2.0 was the semantic web. No, it was Ajax. No, RSS feeds. No, Web 2.0 was about Atom. No. Web 2.0 is XML. No, it's not. Web 2.0 is about SOAP. No, Web 2.0 is about REST APIs on all your stuff. No, it's not. Web 2.0 is about blogs. No, it's not. I'm working on Web 2.0, and we're doing user reviews and user-generated content. And, all of these things, some of them have stood the test of time. Ajax is ubiquitous now. Every website you go to uses Ajax as part of delivering these rich interactive experiences. RSS feeds and blogs, they were really big for a while, and on the back of that, we invented things like podcasts. Originally were a hack based on putting MP3 links in your blog feed, and then those kind of things, as social media took over, they sort of died away a little bit. And stuff like, the semantic web and microformats, there's some people still talking about that, but nobody now says Web 2.0 was the semantic web or microformats. And, what I remember from the conversations at the time was they were all informed by the same objective. We had all these people who'd been on the web since Web 1.0, I guess, and were like, we're kind of bored of reading. We want to be able to write. We want to be able to post things. We want to be able to share our own content, share images, talk to our friends, do these kinds of things. And we don't want to have to install web servers and lease infrastructure to do it. We just want it to be easy and convenient. And most of these technologies were smart people going, I think I have an idea for how we can make that work. So when I look at what's going on with Web 3, I'm like, what is the common driver underlying all of this discussion around things like decentralization and digital ownership and DAOs and cryptocurrencies? And it seems to me like it's just a lot of people going, we're fed up of accepting the terms and conditions. You're all making loads of money. There are trillion-dollar companies out there who got rich off our content. Our words, our photographs, our video, our music, our art. Maybe it is time we said, actually, no, we're done with this. I'm not going to accept the terms and conditions anymore, because the web does not belong to trillion-dollar tech giants. The web belongs to us. It belongs to you, it belongs to me, it belongs to everyone out there with an interesting idea or a beautiful photograph or something that they want to share. And we deserve a cut We deserve, if there is money floating around, we deserve our share of the money, and in return, we're going to spend some of that money on the products and the platforms that we use. So we are not the product anymore, because the web does not belong to the trillion-dollar tech giants. We are not the product. We own the web. It is ours. Aita. Thank you.